Hi, this is Mrs. Villette, and this video is a short introduction to basic function algebra. So by basic function algebra, I mean adding, subtracting, multiplying, and dividing functions. So let's suppose we were given two functions. F of x is 2x squared plus 7x plus 3, and g of x is 6x plus 18. So the first thing that I need to introduce is a little bit of notation. So this notation in part A says f plus g, and that's in parentheses, of x. The first thing we need to do is reinterpret that to mean that they want us to take f of x and add it to g of x. So all we're doing is we're taking the output from the f of x and the output from the g of x, and we're adding them together. So this should just be 2x squared plus 7x plus 3 plus 6x plus 18. We'll go ahead and simplify by combining our like terms, and that's it. Similarly, on part B, we need to understand that the notation is asking me to subtract the two outputs of the functions. So we're taking the f of x and we're subtracting the g of x. The important thing here is that you make sure that you distribute the subtraction on the subtraction of the g of x. So whether you do that in your head when you're combining like terms, or you do what I'm about to do, you actually show all that work. In the end, you make sure you have subtracted both of the terms from the g of x, and so if I combine my like terms, I have 2x squared plus x subtract 15. So I'm just combining all my like terms. The next thing we're doing is f times g of x, and I want you to really pay attention to this notation because that is what is called just a center dot or a multiplication, and later we're going to have a similar looking but different open dot that means something different. But the closed dot just means multiplication, so this means taking f of x and multiplying it by g of x. So I'm writing what my f of x is, and I'm writing my g of x. Now whether you do the distributive property or a window pane method, we're just multiplying polynomials here. So go ahead and do whatever method makes sense to you. So what I like to do is I like to send the first term through, and then I like to move down a line so that I can effectively combine my like terms. So when I do the 7x and that goes through next, 7x multiplied by 6x is 42x squared plus, and then 7 times 18 is 126x, and then when I go and I send this last one through, then I have 18x added to 54. And then you can see that all my like terms are lined up, and I'm just simply adding. Okay, and our last example on this part of the video is f over g of x, and hopefully you've noticed the trend. This means f of x over g of x, so my f of x divided by my g of x. Now we've seen problems like this before, where when we're simplifying we need to make sure we factor and cancel any common factors. So the numerator requires either the AC method, or you can do what's called guess and check factoring. Guess and check factoring is usually pretty effective if the leading coefficient is prime, as is the constant term, because there are only two real possibilities. So I can have 2 and 1, or I can have 1 and 2, and here for the 3, I can have 1 and 3 or 3 and 1. And we just check and see if we got lucky the first time. So I know this gives me 2x squared, 6x, 1x is 7x, just so you can see what it would look like if it didn't work. If I had put the 3 here and the 1 there, then I would have gotten 2x plus 3x is 5x, and we can see that doesn't work. And of course, if this isn't comfortable for you, you can always do the AC method. And then the denominator I can see has a common factor of 6, so I end up with 6 times x plus 3. And then I cancel that common factor and make note of, in my final answer, any domain restrictions. So here, x cannot equal -3. And the reason x cannot equal -3 is in the original f of x over g of x. If x was -3, that would have made our original denominator undefined. That will lead us into our discussion on the next video. So the next video coming up is talking about domains of these combinations of functions.